Yes, I'm ready. Sure. All right, we've got here 49x squared minus 14x plus 1. So if I was looking at this one here right away, you want to take a look and see if you can GCF this. So if I look at this, there isn't a GCF on this. I can't factor out a 7. I can almost factor out a 7 here and here. I can't do that because of that 1. So it's a complex trinomial, so we got to do charting. So we go through our charting method. Luckily, there's not a lot of combinations. Because I need numbers that multiply to be 1, but because I need this minus 14, I'm going to have to add minus signs here. So I have to go through combinations. That's going to give me a minus 14, and that's going to be these two. So you'll see here this factors into 7x minus 1 times 7x minus 1, which is exactly 7x minus 1 squared. Make sense? Yeah. So whenever you have a b value that's negative and you have a c value that's positive, you do have the option of 1 and 1. But if you're taking positive numbers with positive numbers, you'll never get a negative value. So you have to flip it and say, okay, what about 2 negatives? And then you can get that. Right? Just as a quick example, if I would have written this on here, 49x squared plus 14x plus 1, then the combination that worked would have been 7, 7, and 1, 1. You would have gotten that as your charting answer, and then this would have factored into 7x plus 1 squared. Excuse me. So there's those two. I'm just throwing some other questions on the board that are on the iPad here that might be useful. 4x. You can try some of these ones I'm throwing on if you just kind of want to review this with me. These are ones I'm sure we'll take up. Sure, can I do the same? Let's take a look at that one. 9a squared minus 24a plus 16. Yeah, same idea, except for, yeah, this doesn't have a GCF again. So once again, you got to go to your charting. You have 9 and 1, 1 and 9, 3 and 3. And again, because that's 16, I'm going to have to go negative 16 and negative 1, negative 8 and negative 2, negative 4 and negative 4. And you'll find the combination that works here is this one. So this will factor into 3a minus 4 times 3a minus 4, which is exactly your 3a minus 4 squared. Yep. So yeah, same trick with that one. I realize you can't see the screen. Sometimes it cuts that bottom off. Sure, I grabbed these 6 here, but we can wait a bit if you like, Dalal. I can do a question with brackets now. Just new page here. Can try this one. Then we can try something like this. Sure, Nicole. So there's those two Dalal was asking if you want to practice those. And Nicole's thinking with fractions, so could try that one. The fractions ones were typically related to difference of squares, so I'll kind of stick with that. I won't put that on the test. I can if you want, but I'm not going to put that on the test. But we can try this one. All right. You can try these 4 here if you like. Thanks, Mina. Do you want me to take this up yet, or are we okay? Well, I grabbed some questions here we can try later too. But it'll be like the quiz, and then I'll add some of the harder questions that you see maybe on this front page here. So the quiz plus these ones. A little harder, a little more difficult. All right, let's try this. So this is my x and this is my y. So I've got x minus y times x plus y. Yep, both periods. You guys will write, then lunch, and then write part 2. If period 1 students will just have the whole period. All right, so doing this one here, I got this, and then now, again, the brackets around that remind me that I have to do distribution. And I can just drop the brackets here completely. And I just get an 8 here. So I don't know if you got this. Dalal, Dalal, did you get to hear? Anyone else get to hear? Who's ever working on this one with me? Good. We're not done though, right? I have a GCF of 2 here. So I can factor this out. So this is really 8 times 2 times x minus 1. We can put that together. That's 16 times x minus 1 for that one. No, what we did here, Nicole, is we did difference of squares. So we did not expand it out. Like I'm not squaring the first times second times 2, square the last. I'm not doing that. I'm not expanding it out. I'm applying the difference of squares formula to this. Right? So I'm making the observation that it's of the form, right, this form here. Right, I'm using this formula, right, where this is my x and this is my y. Try it with this one, number 2. All right, so for number 2, did the same thing, right? Like that's my x and that's my y. And you can see I'm just, hopefully you're seeing this, this is my x, what I have in pink, and this is my y, what I have in blue. Right, so you have your x minus y, x plus y. And then you just go ahead and simplify this. So this becomes 2x plus 3 minus x plus 3 times 2x plus 3 plus x minus 3. And I'm getting here, oops. This reduces to become x plus 6. And here I get 3x. So I got 3x, the 3's cancel this time. On this one, the 3's cancel. So, I mean, that's about it. If you want, you can rewrite it as 3x times x plus 6, but it's the same answer as before. So there's 1 and 2. I don't know if you guys got that. Actually, there's not more bracket questions. There's fraction questions now. Nicole was asking for fraction questions now. I can make up more bracket questions if you'd like to practice them. Did you guys want to try these ones? Surprised, eh? Surprising. Sure. So if you are looking at 3 here, hopefully you see this as a difference of squares question, in which case we have 2 over 5x squared minus 1 over 3 squared. And then in kicks in your difference of squares, right? This is my x, and this is my y. So this becomes x minus y times x plus y. And that's it. Good, good. Sure. Let me go to 4 here. So 4 is going to be x. So 4 is actually xy squared times 1/2 squared. I don't know if you guys saw that. Did you make that mistake? That's an easy one to make because this is the power of 4. So that would be xy squared. And then again, you can do difference of squares. This would be xy squared minus 1/2 times xy squared plus 1/2. If you are doing 4. But Dalal, since you're working on 6, I can jump to 6. This is my x, and this is my y. So it's going to be x minus y times x plus y. So this will be x. You can distribute that minus sign. And I can drop the bracket on the other one because it's just a 1 in front. So this becomes negative 5 times 2x plus 5. And that's it for this one. It's just negative 5 times 2x plus 5. For 6. Does anyone have an answer for 5? They want me to take up 5 already? Sure. All right, so this is my x and this is my y. So let's check it out. This is going to be x. Oops. Minus y. And then x plus y. Right, just kind of matching these colors here. So I've got the x minus y, x plus y. So now, again, I can drop the bracket. I can drop the brackets on the first one because there's just a 1 in front here, so I can drop that. This I can distribute the minus sign into here. This, again, I can drop the brackets, and I can drop the brackets on that. And then it's a matter of just cleaning this up. So this is like your like terms. You can put these together. So this becomes what? End up getting here negative x plus 4 for the first term. And then 5x plus 2 for the second term. And like we talked about, you don't really want to leave it like this. When the leading coefficient, like when the value in front of your x variable is negative, you should try to factor that out. So we should take this out of the first term, and that becomes x minus 4, and that's left alone. So normally it's written without the 1. The 1 is kind of implicit, like that you know it exists there. You don't have to like actually write it. So a lot of times they won't write it, the 1. And that's the answer for 5. We see. Sure. I think I got that to fit on the screen roughly. Good. So there's a bunch more questions here. Are there any issues with those, like in terms of the steps I did or anything that you guys need? All right. I had left, if I had started to write some questions out. I don't know if you want to work on those, but I also have the worksheet here as well, like below. This is the kind of the worksheet we were going through. If there's questions from there you want me to do, I have the worksheet available so we can reference that. If you have questions with those, or if you want, you can try out these 6 questions here too is another option. Sure, yeah, go ask away, Nicole. Just reference the section and the number. I can do it. Yep. Maybe. Perfect squares part. Perfect squares. Yeah, what? Yeah, I need a number, Nicole. Yeah, the perfect squares part. Factoring perfect square trinomials. These have Roman numerals next to them. You just have to quote the Roman numeral. So I know what section you're talking about. 5, 6, whatever. Rima, what question do you want me to put on the test? Which one should we choose? Easy questions. Easy questions. Okay, Nicole, which one are you talking about? I don't know. Are you talking about the difference of squares here? Like part 3? You have to please quote the Roman numeral 1, please. Like which one are you referring to? Like 3 or 4? Oh, 0 questions, yes. Here, you guys try these ones. I think these are pretty good. I would try these ones here. 1 to 6. All right, so give 1 to 6 a shot here. Try these out, and then I can take them up. And Nicole, just quote the Roman numeral and the number, and I will do the question. So find the question. You'll have to quote whatever Roman numeral it is, and then the number within that section. And I can do the question. The title of it is Factoring Perfect Square Trinomials. All right. Okay, so let me grab a question for Nicole here. We can add that to the list. Oh, I see. Okay. There you go, Nicole. There's 7. So if I were to do this one here, I'll take all these up, but let's copy this. And I'll put it on a new page here for us to work on. Right. So with number 7 here, you've got yourself a simple trinomial. Right, leading coefficient is 1. It's a simple trinomial. I have to think of 2 numbers whose product is 64 and whose sum is negative 16. So the 2 numbers are negative 8 and negative 8. Right, negative 8 times negative 8 is positive 64, and negative 8 plus negative 8 is negative 16. So I need that minus 16 here. So that means that this factors into x minus 8, which is exactly equal to x minus 8 squared. That's it for 7. Those of you working on 1 here, right away if you take a look at 1, you'll see there's no GCF on this, so I have to go right to charting to factor this. And I mean, this combination is not going to work. Oops. Really? I'll check it out in a second, Nicole. We can see. There's a lot of combinations here. For 1, I need a 9. Am I getting that anywhere? I don't know if you guys see this here, but if you take a look at these two columns here, you end up taking 2 times 8 is 16, and then 1 times -7 is -7. If I add that together, I do get that 9 that I needed right here. So I found the combination. Oh, good. Yep, very good. So this factors into 2n minus 7 times n plus 8. Good, good, good. Yeah, 1 was a bit tricky, a lot to go through. All right, let's take a look at 2. So for 2, right away, the first thing you want to look for is a GCF on 2. And the GCF here is going to be, what, 3AB is the GCF on that. So I'm going to be left with 6A minus 5B. Oh, is it AB? No, I think it's 6A minus 5B. Oh, yeah, no, sorry. Rima's answering the GCF, which is correct. Very good. Yep. And that's the answer for 2. There's nothing else to do here. Like, I'm completely done for 2. Oops, I'm trying to move this, but that is not moving. All right, I'll just leave that before I ruin it. All right, for 3 here, again, the GCF for 3 is going to be 4x, and that's it. Did anyone actually answer 3 already? I might have went too fast. I don't know if you guys see, but I can do a difference of squares here. This would be like y squared squared minus z squared squared. Okay. I'll slow it down then. I think so. Number 3, yeah, I'm not going to make it look much harder. For the one there, that 4x one that we did in class, I said I wasn't going to put that on with a number in front, so you don't have to worry about that one. And then now this we can still factor. This will be like y minus z, y plus z, and then y squared plus z squared. That's it. But you need all of that here for number 3. Right, because you do your difference of squares, but then I can do difference of squares a second time. Did you get this here? Number 3? Here, I'll add another one there. Okay, so let me copy these. And we can do these below. Oh, what a mess. What a mess I've made. Okay, well, here's the same questions, practicing more. So we have taken up 1, 2, 3. I haven't done 4 yet. 4 is important, and I wanted to show you 4 because I'm sure you'll see something like this tomorrow. That just because it's written backwards doesn't mean you can't treat it like a quadratic, right? So if you rewrite it, now you have yourself a complex trinomial. Right, I have a complex trinomial, and you go ahead and do charting on this. And that's the answer for 4. Is anyone done 5? Can I take up 5, or should I wait a bit to let you try it? No, you should though, Rima. You shouldn't forget to do that. But yeah, I won't take marks off, I suppose. Yeah, don't worry about Rima. For that one there, oh, is this number 5? Let's check it out and see what you get for 5. Sure. I'm just waiting for someone to be done it. So first thing you do is factor out the 5, which would be y to the 4th minus, this will end up being 16x to the 4th. Right? 5 times 16 is 80. So now I factor that out. So now I want to continue this. So this will be y squared squared minus 4x squared squared. Right? And then I can kind of force a difference of squares on that. Wrote each as a power of 2. So then you're going to say this is 5 times y squared minus 4x squared times y squared plus 4x squared. Very good. And then just as before, you guys always forget to write this 5 down. Once you GCF it, put that GCF back down. And then I can do difference of squares a second time. I don't know if you guys can see, but I can do it once more. Right, where just to save some writing, this will be y squared minus 2x squared. That's how I'll write it. So this will be y minus 2x, y plus 2x, and then y squared plus 4x squared. And that's it. What y is the 1 negative? Is it because of the 8 is negative? Y is negative. Yeah, you can skip Dalal for sure. Why is the 1 negative? Oh yeah, I'm not sure which one you're referring to, Nicole. You'd have to reference the number. Tell me what number you're asking for. I don't see a negative 4. Okay. Oh, I see. For number 4. Yeah, I was kind of talking earlier with Dr. Saturn here. And if you would have just left it, Nicole. Yeah, I understand now. If you would have just left it as 1 and 1, there's absolutely no combination that you could possibly do that's going to give you a negative b value, right? So because of that, the other option, another combination of numbers that come out to be 1 are -1 and -1. But by doing that, then I incorporate negative values. This comes out to -4 and this comes out to -4, which gives me the -8. If I didn't do that, I'd just be taking positive numbers times positive numbers and adding them up. You just have positive numbers. There's no way to get a -8. And I was helping Dr. Saturn with this earlier, and I think we were doing this one, like number 7, for instance. And it was oh no, not number 7. It was, boom. Oh, this one, yeah. Like this question, for instance, was the same idea. Like I needed a negative 24. So 4 and 4, 8 and 2, and 16 and 1, none of that would have worked. I had to tack on minus signs on these to get that minus b value. Right? That's the only way to get the correct answer. So that's that one. Is this it? Oh no, these are the factoring worksheets. Okay, so we're still here. And that's number 5. Number 6, I can run through 6 here. 6, there's no GCF on that, so that 6 is going to go right to charting if you're doing number 6. So 3 and 1, 1 and 3, and then negative 20 and 1, negative 1 and 20, negative 10 and 2, negative 2 and 10, negative 4 and 5, negative 5 and 4. Just tons of combinations for the end one. But I need to get a 7 out of here, and I bet that'll come fairly quickly. Oh, actually, I highlighted the wrong one. I think these two will do it. This will be 12 minus 5 is 7, and that's it. So we should have gotten 3y minus 5 times y plus 4. That was 7. Bracket and fraction and bracket question. Sure. Eight here. I just threw this up because someone was asking for some extra ones. This one is a little bit difficult because I just wanted to remind you, if you have to do a difference of squares, I can write this as root of 7 squared. So then this becomes 4x minus the root of 7, and then 4x plus the root of 7. Yeah, 8 is done. So you're kind of forcing it, difference of squares, by changing the 7 to root 7 squared. So far, so good. All right. There's a bunch there. Okay, so we want some fraction questions. I can do that. Oh, yeah, I know what you mean. Sure. Um, I think that'll do it there. Number 2 should kind of do that. I believe the numbers will work out like that. So this one, so there's one. I don't know if you guys are able to answer that one. For this one, so it's going to be x minus y times x plus y. Then I can distribute the minus sign into here. Anyone get this so far? So now this is kind of like the quiz where like there's a common factor here. So I should factor out a minus 5 out of here. I'll be left with x minus 1. And there's nothing to factor out of here. So this becomes minus 5, x minus 1, and 15x minus 1. Good. Well, that's probably put one of those on the test tomorrow. Probably means yes. Probably does mean yes. High chance, high chance. When I factor out a number with a negative sign, all the signs within the bracket change too. Yeah. Yep, that's true. And that's what you saw here. Negative turned to positive. Positive turned to negative. No, in that case, if you, for example, if you had something like this, let's say we do our math and I get 3x plus 9, and then here I get 5x minus 15. Like, let's say that ends up happening. So here you'd factor a 3 out of the first one, and you get x plus 3. And then you'd factor a 5 out of the second one, you get x minus 3. And then what you do is you combine the two numbers together, because you can move these all around any order you want. So I'd put the numbers together like that, and this would be end up being 15 x plus 3 x minus 3. Yeah, no problem, no problem. In general, if you have a value that's negative, you should factor it out. So like, notice here I factor out a minus 5 instead of a 5 because that value in front of the x was negative. And we even did it earlier in the question I was working on with Rima. It was, where was it? I feel like we did it earlier where I factored a minus sign out again. At some point we did it earlier. I thought I could find it quick, but I don't see it here. Anyways, it's a common sort of thing that we've been doing. Yeah, so if the number in front's negative, you should factor it out. Oh, right here. We had that happen over here, negative x plus 4. I factored the minus sign out and put it as x minus 4. I don't know if I can think of any other ones to ask. Let me see. Could try that one. We've done all these questions. I had left this one on here. All right, so Dalal's saying, wait, if you have a variable with a power, we have to do the charting, but if there's a variable by itself, we do the sum. Yeah, if I gave you something like this here, that's a charting question. If I give you something like this here, that's a product sum question versus a charting question. And that's by product sum. Sir, for the worksheet part 4, can you see what they did since the answer is not adding up? I'm assuming what you mean by worksheet part 4 is you mean the... I don't... Like this is worksheet part 4, but there's 20 different questions. So do you mean like what I have here? Number 2. If I go to the answers for part 4, which are below, if I go to the answers for part 4, it has my answer. It's right here. Here's part 4. This is what I got. X minus 8 squared. See, if you look here, the answer is x minus 8 squared. And that's the exact answer that I got all the way over on number 7, which we did yours first. Right here. Same answer. Sir, can you take up the question you just put up? Sure, Rima. All right, the GCF for this is m cubed. That's it. So this is m squared minus 9n squared. So I'm getting m cubed. So this is my x and this is my y. And back to Mina's point, if it's after you GCF, obviously, because if I give you like if I give you this question, this is product sum, but this is also a product sum question as well, because I can factor the 2 out and then it becomes a product sum, right? So these are both product sum. After you do GCF, right, like after you do your GCF, if you could then have a leading coefficient of 1 that's product sum, else you do charting. Okay. Is there anything else you guys need from me? You done? Are we okay? Okay. Right. I guess if that's it, then like I'll save this stream and you guys can kind of review it. We went through like lots and lots of stuff. So again, tomorrow's quiz is more or less like the quiz we had earlier last week, and then just adding some of the more challenging questions that we've been kind of going through. Probably something like this. Probably some stuff with some messy fractions that you saw here, stuff like that. No, I'll keep everything factorable. It'll all be factorable. I know there was a chunk of questions in the worksheets that were unfactorable. That will not happen tomorrow. At least not by on purpose. Okay. All right, guys. I'll cancel the stream now, and this should pop up if you want to review anything else. Other than that, I will see you tomorrow.